Okay, for the second lecture of the week, we're going to focus on climate change, and in particular on how we can respond to climate change, because that's really where the policy and planning comes in, is in how we're going to respond to the phenomenon of climate change. Often we look at those responses, or we put them into two camps: climate change mitigation, which we're going to spend some time talking about, and climate change adaptation, which we'll also spend some time on. There is actually a third category of action that we're not going to spend really much time on, but that I will put out there, and that's more what we might call geoengineering. I would say it's typically not as prominently considered, although certainly components of geoengineering may be viable. Some geoengineering, frankly, seem a little bit off the wall. But there may be options in which we can also geoengineer. So we really have three responses. But as I say, we're really going to focus on policy and planning decisions in the realms of mitigation and adaptation. And one need not look very far to find examples of the impacts of a changing climate. Venice, coincidentally, this year actually had a better flooding season because of infrastructure built in response to its flooding, significant, horrific flooding that's kind of sinking the city. And so example of an adaptive response. So we speak of adaptive responses. We're going to talk about that in this lecture. And Venice's Mosaic project, which we visit as part of the study abroad, shameless self-promotion for the study abroad there, is an example of a response that's been necessitated, one would argue, because of the impacts of a changing climate. In this case, of Venice literally going underwater. And I should add, by the way, that these are complicated matters, and I hope that's clear and I hope that's understandable. So Venice's sinking or flooding is a product not just of global warming and thermal expansion of the water in any way. In fact, it's the literal sinking of Venice is more of a factor there. Nonetheless, it does have to do with our disruption of climate systems, even though it's not our climate system in the sense of global warming in that case. Not our climate systems, I'm sorry, our systems, our geological, environmental, atmospheric, all of our systems, right? And so we built in a lagoon, and it has consequences, right, in terms of the subsidence that Venice is experiencing, and thus the flooding. Nonetheless, we certainly see patterns over time in virtually all of our coastal environments that suggest that we could be in for a lot more flooding as sea levels do rise, as polar ice caps and glaciers melt, further contributing to sea level rise, and so on and so forth. Second issue is certainly wildfires. Sadly, year after year, we seem to see more and more examples of these catastrophic, just completely devastating, very sad wildfires. And a really important idea or notion that these are not sort of abstract of climate change, that these are very inextricably linked to human-caused climate change. And that's important, right? And again, there are other factors, not the only one. But as we remember, we talked about a few weeks ago in forestry, there's lots of reason to believe that climate change is a factor there. And yes, even in some ways that maybe we don't want to think about or openly acknowledge, that there are maybe ways in which climate change is even changing us or changing our physiology or biology. And so certainly many reasons why we may be concerned about the impacts of climate change. And we think about the changing climate, typically what we mean by that, or the core of that, is rise in temperature. The rise in temperature translates into many other impacts, right? So we just talked about sea level rise. But the sea level rise is a result of rising temperatures, right? And so the relationship is that the warmer it gets, two things happen, right? One is that we have thermal expansion. That is, the water warms as the air warms. And thermal expansion occurs, and water that's warmer takes more space, essentially, and expands. But we also see warming causing to increase melting of again, polar ice caps, glaciers, and so on, and therefore more water in the oceans. And then, of course, there are other effects as well, right? So, for example, as temperature warms, we see more energy in the atmosphere, can lead to more intense storms, and so on and so forth. But at the core, below all this, is a rise in temperature, and that's pretty hard to debate. I think it's pretty hard to in any way say anything or conclude anything from the data other than the fact that it is getting notably warmer. And so you can see these graphs of temperature measured in there's many ways in which we can measure temperature, but the global mean temperature over time, looking at 1850 to 2000, and I'm not sure when that's finishing, 2000 something, is unquestionably rising. And one might ask, why, right? Why is global warming occurring? And again, pretty unequivocal connection here made. Yes, there are some holdouts, but they're pretty few and far between that don't believe at this point that climate change is inextricably linked to human behavior, and that is through the emissions of what we call greenhouse gases. It's important to note that these gases are a natural part of our atmosphere, right? And I'll go a step further than that. They're an absolutely essential part of our atmosphere. We would not have the consistent, moderate temperature we have as a planet if we did not have the layer of greenhouse gases that serve as sort of a blanket over the Earth. So this layer of this blanket, if we imagine it as such over the Earth of greenhouse gases, serve a really important function. What happens is that solar radiation comes in, it warms us up, and that blanket, those greenhouse gases, hold that heat, right? They hold that energy as heat. And if it wasn't there, we would have massive temperature fluctuations like we see on planets that don't have an atmosphere like ours, or have no atmosphere, right? Or virtually no atmosphere, where the temperature when the sun is directly hitting the surface of the Earth goes up to the hundreds of thousands of degrees and then drops to the minus hundreds of thousands of degrees as the sun sets on that part of the Earth. And we don't have that, right? We have relatively moderate temperature because of what this does. The problem is that those gases are good at that, and that the more we put in the atmosphere, the more they will capture of that energy. And that we as a species, and particularly we as a species, are actually quite sensitive creatures. We personally, and through our dependence on other flora and fauna, depend on a climate that exists within relatively narrow bands in any given place. And when we disturb that through warming the atmosphere, it can have consequences, as we said already, on things like thermal expansion of the ocean, on things like melting the polar ice caps, on things like leading to drought in some areas, leading to things like intensive heat waves that cause serious harm to human health and other systems. Long and short is that these greenhouse gases have been going up as a result, and precipitously up, as this graphic shows, as a result of human activity. And so since the Industrial Revolution, we've seen a significant increase in the parts per million of CO2. And by the way, CO2 is the most commonly talked about greenhouse gas. It is the most common greenhouse gas, and that's why. But there are other greenhouse gases that are much more potent. So for example, methane, we emit less methane, but methane is a much more potent gas or molecule at holding that heat energy. And so we have to be concerned about things other than CO2, even though we tend to talk about it as CO2 and use CO2 as a measure of our greenhouse gas concentrations. But as you can see, really significant rise in those, concurrent with a significant rise in global temperatures. And those changes have significant implications. And so rising seas, global warming, all these things have major implications. And this graphic, I think, is really not less depressing, but also useful at understanding what those are. And so things like malnourishment due to drought and changing food supplies, things like 35 million plus affected by floods, ocean acidification, for example, is killing coral reefs, threatening peatland ecosystems, which has both a loss of those important ecosystems, but also in terms of releasing methane as the peat dies. 1,600 deaths associated with heat waves and wildfires, 1,600, so quite a significant number. Displaced people, a significant number, and belief, and there's a connection in displaced people, migrants and environmental change. Decreased global ocean oxygen, which has impacts on our aquatic species. And massive displacement due to weather, things like hurricanes and so on and so forth. So very sad in many ways, but important to understand and appreciate the various areas in which this impacts can occur. And of course, we can look at the impacts sectorally in virtually any sphere, but one that's particularly pronounced, and one we don't pay a lot of attention to in this class, but is human health. Just the various ways in which climatic change is leading to some obvious and some not so obvious potential impacts on our health and well-being. And some of these are quite significant, right? And we may think of as as a little bit of a broader interpretation of human health, but things like the ways in which increasing CO2 levels seem to be leading to environmental degradation, potentially leading to forced migration, civil conflict, and so on. That's pretty substantial. But some of these are less, more directly, I should say, public health related. So changes in disease vectors, something certainly talked about, and how that can lead to increase. And we see that, right? We see what we traditionally thought of as tropical disease is creeping further and further north in the northern hemisphere, and I suppose south in the southern hemisphere. Things like malaria, dengue, syphilitis, and so on and so forth. Lyme disease, obviously, is a good example, right? When I was a kid, it was pretty rare to hear of Lyme disease. Now it seems like I pull ticks off my dog all the time, for example. And so that, at least there's some suggestion that's connected to climate change. And if you want to get more specific or precise on what climate change projections are, I've given you some links here. These weren't required readings for the week, but I would definitely suggest you take a look at it, especially if it's of interest to you, but just for any of you, to get a more specific or nuanced perspective on what climate change looks like, what trends trends or forecasts we see, for example, for coastal Virginia. Not just coastal Virginia. I was involved with, served on the committee here in Blacksburg looking at climate vulnerability. Just finished our work, I guess, a few months ago here. We don't think of Blacksburg as particularly vulnerable, and frankly, compared to many places in the world, it's not. But even here, some concerns around things like potential shifts in precipitation. Even though we obviously have a more moderated climate because we're in the mountains and so on, we won't have the same heat stress as places like Richmond. We certainly can have, we could see shifts in warming temperatures and that could increase the number of heat wave days we have here. It's useful, I think, interesting to look at. So climate change is almost certainly the most pressing issue, or at least in the environmental sphere, of our lifetimes, and that necessitates attention to governance and decision making at virtually all levels. For a variety of reasons we'll come back to in a moment here, global is certainly one piece of that, global climate change governance and negotiations and around that governance. And the IPCC, the Intergovernmental Panel on Climate Change, plays a central role in facilitating that. It supports the work of the United Nations framework and the implementation of the United Nations Framework Convention on Climate Change, which is the main international treaty on climate change. There's various pieces of supplementary or complementary negotiations, of course, that have, many of them have been very prominent and important, that have supported that work of both the UNFCCC and the IPCC. And those include, for example, the Kyoto Protocol, the Paris Accords. These should all sound, Paris Agreement, these should sound to be familiar names to you. And so if you think about the Kyoto Protocol, at its time was certainly considered fairly aggressive by today's standards, probably not aggressive enough, but at the time was considered fairly aggressive. But of course, really met with, I was going to say mixed results, but that's probably charitable, relatively poor results. So countries like the United States actually signed it, but then of course never ratified it because the Senate refused to do so. The countries that were signatories, so my home country of Canada, we can pick on Canada for a moment here, blame Canada. Canada signed it and then proceeded to wildly exceed the things it had committed to by, massive amounts. So in other words, never live up to that commitment, which raises a whole other set of issues around enforceability of these. We of course then had Paris, which, was at least a marker in the sand, an aspirational marker in the sand. But again, the United States signed it, of course, and Trump famously withdrew from it. The incoming Biden administration has committed to rejoining Paris. But again, even if countries, the bulk of the countries, the bulk of the world's emitters join an agreement like that, real questions around whether they're going to be sufficient. But nonetheless, we have this global framework, right? We have yearly even COP meetings, Conference of the Party meetings, where this work is conducted, where the science is investigated, where negotiations happen on what future climate agreements might look like. So the IPCC essentially is the scientific and intergovernmental organization that's responsible for vetting, mediating, and interpreting the science that informs those meetings, and informs those Conference of the Party meetings. That's really important work, and it's a key piece of thinking about the global climate governance issue. I'm going to ask you to watch this short video on the Climate Change 2014 Synthesis Report. So it's basically a synthesis of the findings of the IPCC that, again, are informed. It's a robust process to inform decision-making where scientists from virtually all over the world are co-authors together on this massive report. It's supposed to reflect the scientific consensus, and not just consensus, sometimes disagreement, so the breadth and how much agreement there is or disagreement there is on different pieces of the science. But it's a really robust, I think, example of science policy interaction where we have this group of scientists that are they're deliberating among themselves, and they're ultimately tasked with framing the research, the conclusions, the reflections on the data, to decision makers in a very clear way, in a very way that's I think meets the criteria of saliency, credibility, legitimacy, right? So that's very salient, relevant to their decision making, follows scientific standards of credibility, and is legitimate because it's seen as, this isn't kind of the biased scientists from one group or from one country even. It's the scientific community, and so a fairly robust process. And the report, the climate change impact assessments the IPCC, or not impact assessments, sorry, the climate change reports that the IPCC puts together, this just kind of repeats or reinforces what I said before about how they involve all these authors from different countries. They open up for a commenting period, and it's broken down into different working groups and then ultimately different reports, right? And so in this one we see the physical basis, where it talks about the unequivocal warming of science, talks about how it's almost certainly largely a consequence of human-induced climate forcing, radiative forcing from emissions of CO2 and other greenhouse gases. That the human relationship is clear, right? And the continued emissions of greenhouse gases are going to cause further warming and changes that are going to lead to substantial change. So that limiting that change is going to require substantial and sustained reductions of greenhouse gas emissions. And so this is the physical science behind it all. And what is the manifestation or results of that physical science, of those physical changes in our atmosphere and other systems? Those are presented in the second working group report, which is on impacts, adaptation, and vulnerability. So it outlines what are the expected vulnerabilities and how can we respond to them. And a couple things come through pretty clearly, right? One is that because risk and impacts are at that nexus of hazards, exposure, and vulnerability, that they're differentiated, right? We know that there are differentiated impacts and differentiated adaptive capacities. And in some ways, that's kind of the sad part, right? So the countries that are the most responsible, ironically, for emissions often have more adaptive capacity to adjust as the climate changes and adapt effectively, whereas countries in the global south that are per capita at least much less responsible for greenhouse gas emissions often have the least resources to adapt. And so part of what thinking or negotiation that goes on here is, at the very least, how can we support countries in the global south in their efforts to or need to adapt? And more specifically, insofar as mitigation is one of our necessities, one of the things we have to do, how do we do it, right? What does mitigation entail? And basically, mitigation, as it says, is it's a human intervention to reduce the sources or enhance sinks of greenhouse gases. And that enhancing the sinks can be important, right? Some of that can be, sort of geoengineering, things like carbon capture and sequestration. I said in seminar, even some crazy things like, putting mirrors in space to reflect the sun's radiation. But many times also things like just protecting forest cover that we have. And so there's been a lot of schemes through things like RED, which is forestry negotiation around forestry policy, to essentially subsidize the protection of things like the Amazon. So as a way to recognizing their importance as a sink of greenhouse gases. And there are various issues that are dealt with, right, as we think about mitigation of climate change, right? Issues of equity, justice, and fairness in terms of things like mitigation and adaptation. How do we assess the efficacy of certain options and their viability? Do we look at things like an economic valuation, which is often what we use? But is that sufficient? Does economic valuation get at everything? Does it maybe privilege some things at the cost of others? And I'm going to ask you to watch this short video on the Paris Climate Agreement, which gives a sense of what that looks like. And it's, of course, a rosy picture on when countries get together and do reach agreement on global action, which, as I've already said, doesn't happen enough. Although this is a nice segue into where we're going to wrap the semester around global negotiations. And it's useful to look at times and examples of where the world has got its act together and coordinated internationally. I'm also going to ask you to watch this short video that gets at one of the ways in which we can respond. Because we think about, it's one thing to make these commitments, it's one thing to acknowledge the problem. It's another thing to think about how do we implement this, particularly as we start to move down to the national level. Although emissions trading certainly can happen between countries as well. For example, within the European Union, there's a ETS, European Trade System, emissions trading system, that is a robust carbon trading system, carbon credit trading system in Europe. So I'd like you to watch this video as well, just to learn a little bit more about that as a potential response. Of course, there are other things we can do. So we think about carbon emissions trading, and so often we think about fixed sources, right? So trading of carbon credits between, say, power plants or other industries. But a lot of our emissions are, of course, from non-point sources, right? And particularly from our vehicles, right? From our transportation sector. And in that case, there are other policies we can look at. So, for example, the Obama administration adopted more aggressive CAFE standards, right, which are vehicle fuel efficiency standards. And as you can see, they really push auto manufacturers to increase their fleet-wide average fuel economy significantly, right? It's supposed to get to 50 something, what is it, 60 something percent by 2025. Of course, there's been negotiation there around, that's for cars, I'm sorry. So if you look at the average, it's 54.5 between cars and light trucks. And of course, we've seen that there's been pushback on that. The Trump administration has been reversing various things like this. But nonetheless, these are the kinds of policy instruments we can achieve. And of course, I already mentioned the United States pulling out of the Paris Agreement as an example of the ways in which, that's democracy, I suppose, is that we see these actions, but they can certainly they can go back and forth, right? And so many of the things that the Obama administration had agreed to or had implemented or adopted in this area of climate policy, especially when they're executive orders that didn't require legislative change, the Trump administration has shifted on. But of course, those shifts can and do happen in both directions, and so one might ask, or not, and then or not again. Joe Biden, as many of you may have seen, has committed to rejoin Paris, and certainly has made climate change a key pillar of his plans, of his platform to go forward. So things oscillate back and forth, and we'll see where we end up next in terms of global agreement, and in particular the United States' role in that. But even beyond that, it's important to note that even in the absence of federal action, there's been a lot of action on climate change mitigation and adaptation, and notably mitigation in the absence of federal action in the United States. And so federal government has been very slow to take decisive action to implement these agreements. Kyoto obviously wasn't even ratified. Paris, not really acted upon. But in that absence, we've seen states, and of course not every state, but some states take a lead, and even cities. And so this is a news story from New York City that New York, when Trump was pulling out, was busy saying that they would uphold the agreement. And essentially, they can't sign the agreement, but would reduce emissions commensurate with what their responsibility would be as if the United States had signed it. Regardless of what federal policy is. And that's really an interesting, pro and con of the federal way the United States works, is particularly states, sometimes cities to some degree, especially if you're a city as big as New York. But especially states really can choose different policy paths. And when it comes to international agreements, they're not sovereign, so they can't sign an international agreement in their own right, but they can do things that essentially live to the letter of what that agreement would be. And of course, then there's adaptation, and unfortunately, there's adaptation. And there's a news story; it's a couple years old now, but around the governor signing an executive order to protect the state against climate change catastrophes here in Virginia. So, Governor Northam, one of his key legislative agendas was to advance planning for climate change, given that especially coastal Virginia is very vulnerable to changing conditions. And it's unfortunate we have to think about adaptation, but it's a reality, and certainly one that decision makers are starting to take seriously at all levels of government. And some pieces of that look like urban planning, right? And so I try to mix in some policy, or in addition to policy, some planning. Here's an example of a planning-related project. So after Hurricane Sandy, there was a lot of money put into this process or project, or whatever we want to call it, called Rebuild by Design, where different states pitched projects and essentially received funding. So as you can see, in 2014, President Obama launched it, this National Disaster Resilience Competition, and awarded $1 billion to 13 cities and states across the country to fund resilience building projects. That is to increase our infrastructure to enhance our adaptive capacities. And $120 million of that came to Virginia. So no small chunk of change came to the Commonwealth for supporting adaptive infrastructure in our coastal environments. And I believe that's Norfolk. I could be wrong in that image, just showing the kinds of things that we can do to shore up our landscapes, our environments, and mitigate or reduce the risks posed by climate change to our built environment. And on that note, thinking of planning, and not just planning, in fact, mitigation, adaptation at the local levels, I'd encourage you, and if we were in class, we might do this as a class exercise, but to take a look. I mentioned already that I was involved with Blacksburg's resilience assessment. I don't believe it's been published yet, but it will come out at some point here. But Blacksburg does have a climate action plan. Certainly cities like New York, Rotterdam have been at the forefront. Norfolk here in Virginia has an Office of Resilience. Washington, for those of you from Northern Virginia. I encourage you to take a look. Look for keywords like climate action plan, climate mitigation plan, climate adaptation plan. And you'll find that many cities around the world, and certainly here in the United States, have robust plans. I'm not saying they've necessarily got very far with implementation, and in fact that's one of the challenges, but that in terms of at least forecasting where we may end up and thinking about what we can do in response has certainly been a task that cities, states, and to some degree the federal government have taken up. Okay, and so hopefully one thing that came through from climate change was that at least when we talk about mitigation, it is a global problem. Greenhouse gas emissions don't care where they came from. They go into the atmosphere and they cause global warming. And so therefore the solutions arguably have to be, at least the mitigation solutions have to be at least a component of them global in nature. It requires coordination, agreement, negotiation among countries. Of course, it's not the only issue that's global in scope like that where we need that kind of negotiation. Another example is mercury, and that's where we're going next. Mercury negotiation is a little bit is I think an interesting example. It's relatively successful, right? So countries got together, they signed the convention, and they've more or less lived up to those commitments, or at least are working towards living up to them. It's not the only example that's positive, but it's a good example of one that's probably a little more positive, frankly, than we've seen with climate change. On that note, I'm going to be posting some stuff this week to prepare for that negotiation simulation, and I'd ask you if you can to take a look, especially at the general instructions for the role play exercise. I realize it's tight. Class is 1:25 on the Monday right after the break, and doesn't give a lot of time to prep. But if you can, amidst turkey eating, take a break. Don't do it amidst turkey eating. But as you start to pivot back into thinking about school again next Sunday, or before Wednesday, if you're trying to get things off your list and you get a chance to look at them, I think it's going to be better for us all if you're teed up for Monday or Monday morning, worst case scenario. But if you could make sure that you're ready for that, I'd appreciate it. And on that note, just a final reminder, we're all going to be together on all 3 classes the week after Thanksgiving, and then both classes the week after that, so please be prepared for that. Please be attending. If there's some reason you really cannot attend a class, I'd prefer to know. Please let us know ASAP. Otherwise, we're expecting you there, and it's actually required, so we're expecting you there. Okay, thank you, and happy Thanksgiving, everyone.